I'll drive the slides. Just I'll put Mary's hat on for a second. Mary has had to say she can't join us today, but Mary from NHS England does the introduction for this. So this is about decarbonisation through the national hydrogen rollout, and we're lucky enough to have Sally from Cadent, who's very involved in this, to help with that. And it's highlighting hydrogen from carbon capture as a route to net zero. And I'm sure Sally will explain to you why it's carbon standard, compliant and clean. It's not dirty carbon, it's clean. And then we've got Eric, who's going to talk to us about a different route to hydrogen. And then we've got Alan, who's going to talk about the fact that CHP need not be a stranded asset. Okay, and then we'll have a brief update about what's happening next and what's happening at AHEM. So the overall program is about the routes to net zero. The routes to net zero are geothermal energy, hydrogen energy, district energy that is green, and then air source heat pumps, to which we put in alternatives of decarbonisation of gas as a way of getting hydrogen, and some other techniques which are covered in next week's workshop. So there are techniques for people stuck with air source heat pumps, and we can help you with those. But the main routes are through the three measures I've covered, and hydrogen's the discussion today. So I'll show you the NHS map. This is the map of all the 209 biggest trusts. It shows you the hydrogen producers in one green dot, the greener green dots, and then the bluer green dots are the hospitals that could potentially benefit from that hydrogen. We have all the trusts invited to this on a map. You'll see the map at AHEM workshop, and we will make your entries on the map available to you, ready for the roadshow, which I'll discuss later in this test. But you can see where you clustered and where you are. But we have Eric with us, who will explain why, even if you're not near those clusters, you have a potential for hydrogen a different way. So I'll hand over to Kate now and Sally, fresh from the rollout in Derby last week, to explain to us what Cadent and the various suppliers are doing.
Thanks, Clive. Yes, so I'm Sally. I'm Head of Regional Development for the Eastern London for Cadent, which is the UK's biggest gas distribution network. Could we move on to the first slide, please, Clive? Thank you. So here's a map of our network area in the orange. So we supply around 12 million different supply points across that region, and we've got a lot of pipeline in place. It's our strategy to repurpose our gas networks to hydrogen, and what we're doing to start to achieve that is we're focusing on industrial, commercial and power generation decarbonisation. So they're the sorts of customers that we're talking to, and hospitals fall within that on the public sector side, obviously. So hospitals use about the same as, or a large hospital will use about the same as one of our very large industrial gas users. And that's why I'm here today, to talk to you about what role hydrogen could potentially play in your decarbonisation and show you the regional programmes that we're running. So if we move on to the next slide. Just before I show you some maps, I just wanted to give you some background on hydrogen. So government is enormously supportive of the development of a hydrogen economy in the UK. This is a big list of the publications over the past few years that have had a focus on hydrogen. The one that I wanted to particularly draw your attention to was the hydrogen production business model. And the reason I want to focus on that is because through that mechanism, there is an ambition from government to support the development of hydrogen production in the UK, much in the same way as they have subsidised offshore wind for the past 13 years. Government wants to use a contract for difference mechanism, which will, the aim is to bring the price of hydrogen to the end user in line with the prices of natural gas. Obviously, this will be, the cost is a really important consideration for you in planning out what net zero energy source you'll be using. Next slide, please. So we've broken down our network area into 5 main schemes, and I cover the eastern one, so East Coast Hydrogen. I share the Hydrogen Valley footprint with my colleague Helen, who covers the west, and also the Capital Hydrogen region, which you can see there. So these programs tend to be collaborations with other gas networks. So East Coast Hydrogen for Cadent, that means the East Midlands and South Yorkshire. But it's a collaboration with Northern Gas Networks, so it also covers the Northeast, and then National Gas are getting involved in all of our programs because they're the transmission scale gas organisation. So Capital Hydrogen covers the whole of the east of England and London, and Hydrogen Valley, it's the main regions that it covers are West Midlands and then Peterborough and Cambridge. But a lot of the hydrogen, most of the hydrogen for the Hydrogen Valley will come from Bacton, which is out on the coast of East Anglia, which is why it stretches all the way across. We need to consider that source of hydrogen within that programme. So these are 100% hydrogen programmes that are focused on getting hydrogen to industrial, commercial, public sector organisations in these regions. Next slide, please. So East Coast Hydrogen and HyNet are on this map. I'm going to talk about East Coast Hydrogen in more detail because it's on the east, but my colleague Martin can answer any questions you've got on HyNet, which is in the northwest. So you can see from the map that essentially we want to build a big hydrogen pipeline, and it won't be just a single line like this. There will be spurs coming off to supply hydrogen to the main conurbations in the East Midlands and South Yorkshire. And this programme is currently at pre-feed stage. So we're in the pipeline routing and phasing stage, and that piece of work will conclude at the end of October. Now, working with Clive and Mary, we have made sure that any of the very large gas using sites within the NHS are included in that pre-feed study for consideration as part of the routing study. So if you're interested to use hydrogen as part of your decarbonisation plan, your site has already been considered. And so we, when the end of the pre-feed comes, we can give more information on what that's telling us as to how easy it will be to get hydrogen into your sites. So you have been included, and I'd be delighted to hear from anybody within this region who wants to find out more about that work and to get and we can go through the things on a site-by-site basis for you. Next slide, please, Clive. So it was just to show really that these schemes are supported by industry, and I think this is, you've got the East Coast Hydrogen Consortium group along the top, and then the Capital Hydrogen group along the bottom. And it's really important that we get your engagement so that we can move to the next design stage for East Coast Hydrogen, which will be FEED, which is why we'll be reaching out after the pre-feed's finished to discuss your sites and firm up any potential plans. Next slide, please, Clive. So this focuses in on the Capital Hydrogen region, but this is our one of the hotspots that we're developing within the East of England and North London region. I thought it was helpful to show some detail really on one of our pipeline initiatives that's sort of being developed. So this pipeline will connect production of hydrogen in the Thames Estuary and also imports in the Thames Estuary with industrial customers all along the north bank of the Thames, and finishing up at the Tate and Lyle sugar factory, which is in East London in Newham. But we are developing hotspots like this elsewhere. So we have more in development. There's one in and around Corby, which is in the South East Midlands. There's also potential for a cluster within the Kings Lynn region. And lastly, Felixstowe and Harwich, there's also already activity going on hydrogen production, and we're just looking at what pipeline infrastructure might be needed around there. So, and lastly, I should mention as well that Bacton is slated to be one of the really big hydrogen production centres, which could provide an opportunity if there was interest in from any hospitals close by, like in Norwich. I think that I'm almost finished, aren't I, Clive? Is there one more slide? Yeah, so this is just to say that if you're interested in hydrogen, for your decarbonisation plan, then please do get in touch, probably through Clive or Mary, and we can have a chat with you as to the status of your sites within our programmes. So please do reach out. Are there any questions in the chat? I haven't had a look.
Will you have a look at that and then answer that, and we'll proceed into the next one we can, and we hand over to Eric to talk about other sources of hydrogen.
Sure.
Are you on mute,
Take myself off mute first. So thanks, Clive. Thanks for the opportunity to talk to you also. I'll give you a bit of a kind of overview of what we're doing and, you know, the potential for hydrogen supply into kind of large gas user sites in advance of the networks that Sally touched upon being in place. So if we can move to the next slide, please. So just by way of background, Carlton Power, we are an independent energy development company based in the UK. We've been around since 1995, and since then we've enabled about £1 billion worth of investment in UK energy infrastructure. And what we are about is developing realistic projects and getting to a kind of final investment decision. In terms of our hydrogen projects, our first 3 have been invited for negotiation under the first subsidy allocation round that Sally mentioned. So that will enable us to provide hydrogen at cost parity with natural gas. We've been focusing on kind of large industrial gas users with a low barrier to making a dual fuel switch. And in terms of how we deliver this, we've established a joint venture with Schroders Greencoat, which is called Gecko, which will enable us to deliver the projects. Schroders Greencoat is an international investment company who manage about £8.8 billion worth of funds, and through those control about 10% of all the UK renewable generation assets. And you know, we are kind of very committed to kind of increasing our volume of hydrogen production between now and then. In terms of kind of linking into the wider network, I think what we see is a kind of initial phase of delivering some discrete projects by kind of private connection, and then ultimately being incorporated into the wider network, which is what we've seen happen on all energy systems within the UK. If we can go to the next slide, please. And just if we kind of go on the first one. So, you know, in terms of that kind of building that infrastructure, I think what we see is you have that kind of limited amount of infrastructure, use the existing infrastructure where possible, minimize the availability or the new equipment required, improve the reliability. And in that respect, what we see is, you know, direct hydrogen production proximate to off-takers and a direct pipeline in. That will then enable the kind of build of an expanded network, and this is a distribution network that Sally touched upon, and that will also enable the expansion of off-taker types and improve the resilience. And then if we go for the next one, and then finally, that's where we get that kind of massive network interconnection. So if we think about what the electricity and gas network looks like now, you know, there's a combination of generation assets, there's some storage assets, there's some import and export, and there's a large amount of physical infrastructure in place in terms of gas pipelines and electricity network pipelines that connect them all together. And that's that kind of mega infrastructure that we, you know, there's a vision of that being in place by, you know, 2050 for the UK to have a kind of hydrogen economy. And then if we just press on that, and in that respect, I think what we see is that combination of small and large projects being needed. So it's not just about the kind of large blue hydrogen projects or the large gas networks. It's also about kind of smaller projects. I think one of the things we've identified is, you know, if you look at carbon emissions from the UK, about 50% of all carbon emissions come from the heavy industrial areas. The other 50% come from, you know, the wider area. And what we see is the need for hydrogen production and tools for decarbonisation to be spread throughout the UK and into kind of some of the less industrial areas, and that will require a bit of a cluster approach. I'll touch upon the kind of projects that we're working upon now, just to kind of give you a flavour, and then you know, if it aligns with what you're doing, then hopefully you kind of get a sense of where these things are already happening. So if we can move to the next slide. So first project is Trafford Green Hydrogen. So Trafford is the largest consented green hydrogen scheme in the UK at 200 megawatts. We're doing an initial 15 megawatt project, which will provide hydrogen into Saker, who are a paper mill. Seca have a gas turbine plant, so a fairly large gas turbine plant that already has the technical ability to use hydrogen with some minor modifications and some additional plant added. And we can provide hydrogen, which gives them about 10% of their total energy needs in a way which doesn't compromise their kind of technical robustness of the site and their energy security. At their site as well, we've also got the potential to connect into the gas network at Partington, which is where HyNet will come into Manchester. And in the initial phases, we'll deliver hydrogen by a private pipeline, but in the longer term, we have a desire to be able to deliver the hydrogen via either the network or via tankers. If we can go to the next one, please, Clive. Project number 2. So this is at Barrow in South Cumbria. Again, a kind of area that wasn't going to be kind of connected to hydrogen network fairly quickly. So we will build a 30 megawatt electrolyzer, and that will provide hydrogen into Kimberly-Clark. So Kimberly-Clark, who are the producer of Kleenex, Andrex, Huggies, etc., they will use that hydrogen in boiler plant. So they will replace the existing boilers, which are 100% natural gas, with newer, higher efficiency boilers, which have the ability to switch between hydrogen and natural gas seamlessly. And then that will provide up to about 60% of their energy input. And that is steam raising plant used within their process. Again, you know, there's a partnership there that we've put in place with the likes of Cadent and Electricity Northwest to bring this forward. And we are looking at additional off-takers where we'll may be able to connect them in and provide additional hydrogen. I think this site itself is probably about a mile from the nearest NHS hospital. So there's a kind of discussion about how we kind of bring hydrogen potentially into there. So if we go to the next slide, please, Clive. And then the final of the 3 projects where we've been shortlisted for negotiation with government for the hydrogen business model. This is at Langage, which is just outside Plymouth. This will be an initial 10 megawatt project, which will provide hydrogen to international mining companies, Imerys and Sibelco. The hydrogen that they will use there will be in a combination of their kilns that they use to process their product, but also in a gas engine based CHP plant where they will use a volume of hydrogen to offset the natural gas. And again, it's something that we think it kind of delivers to the kind of hydrogen, the carbon reductions immediately. And for this area in the previous project in Barrow, we've seen them as being kind of almost lighthouse projects for bringing decarbonisation into regions which may have to wait a little bit longer for the infrastructure to be in place. So there is a kind of concept of building projects within the infrastructure, and then when all of the new infrastructure comes into place, we can connect in. If we can move forward to the next slide, Clive. And then the final project, so we announced this fairly recently. This is in Stirling. So Stirling, where we'll have an initial 10 megawatt project, and that will provide hydrogen into Superglass. So they make the mineral wool insulation and have very high temperature requirements. And again, that will displace a volume of their natural gas within their existing equipment, and we'll provide a direct pipeline supply. If we could just go to the final slide. So I think in terms of some key dates and probably the key thing in terms of when we can bring it to you. So I think kind of often the questions that we have is, you know, we want to switch to hydrogen. Where will it come from? How much will it cost? When will it be available? I think the where is, you know, we can build projects kind of to meet demand in specific areas, and we can do it kind of in close proximity to the off-taker. The kind of how much element, I mean, Sally's already touched upon that in terms of the hydrogen business model, providing price parity. And then I think in terms of the when, so on our first 3 projects, we're looking to get the award of the low carbon hydrogen agreement that we're in negotiation with by the end of this year. That will enable us to make a final investment decision early next year, and then first hydrogen coming out of those projects in late 2025. There is a second allocation round, which will open up at the back end of this year, and that will be for submissions in Q1 2024, and that will enable hydrogen production from 2026 to 2029, depending on the specifics of the project. And then there will be further allocation rounds between now and 2030 and beyond in order to deliver the volumes required. The government are looking at 10 gigawatts of hydrogen production by 2030, of which 5 will be green hydrogen, which is the hydrogen that we're looking at. And the first allocation round is looking at 250 megawatts. The second allocation round is looking at 750 megawatts, and therefore there's another 4 gigawatts which need to be filled from the subsequent application round. So there is an opportunity that if we can find the right projects in the right locations and get the right level of infrastructure in place, that we can bring hydrogen into your scheme fairly early and start the decarbonisation process. And that can be either as part of a kind of complete 100% switch across to hydrogen, or it can be part of a transitional arrangement with a limited quantity of hydrogen coming in to displace some natural gas while the kind of network gets built around it. So my contact details are there. Please do give us a follow on LinkedIn, and you'll kind of see what we're up to in the hydrogen space. And if any of you want to reach out directly, more than happy to have that discussion directly with you.
Excellent, thank you very much. And I'll pass over to Alan, who will explain to you about CHP.
Yeah, good afternoon. Alan Beach, Director of Clark Energy. If you could go to the first slide, please, Clive. Switch my camera off. I'm not getting any chat messages up. Right, okay. This sets the scene for the foreseeable future, 3 to 5 years hence. This slide is the UK generation stack, which shows that even on the greenest days, we remain heavily dependent on mains gas for our electricity. This month, we set a new record of 27 grams per kilowatt hour, but we still had over 14% of our electricity generated by gas. So burning gas at our traditional CCGTs, whilst efficient for producing electricity, any advantage is lost through our transmission to our point of use and does not make use of its waste heat, as does CHP. So whilst we use gas at these CCGTs, your CHP's electrical content could be considered neutral, and the heat generated as a means for offsetting carbon until other options such as hydrogen, etc., become commercially available. Next slide, please. So when hydrogen comes, will your asset become stranded? No, we have the technology now, and yes, most existing systems can be upgraded at the appropriate time, which I'll now expand upon. If you could do the next slide, please. So generally, as just described, here we see the two types of grids that we'll see on the system. There'll be the existing system repurposed, initially blended with gases of natural gas and green biomethane and up to 20% hydrogen. And then there will be the hydrogen clusters, where we see a dedicated hydrogen grid connecting them together. Next slide, please. Right, just some technical stuff. This shows the effect of blending hydrogen into the mains gas, the various percentages, what happens to the wobble index, the methane number, and the effects on the lower heating value of the gas that's going in there. So basically, we will need to deal with a greater volume of gas than you do today. Next slide, please. This slide shows the decarbonising benefit of mixing hydrogen. It is small in relation to its percentage blend. As this shows, for that 20% blend, you're looking at a 7% decarbonisation. That again is because hydrogen, to get the same calorific value, you need 3 times the volume of that for CH4. But it is a reduction, and it's also, there is also the renewable biomethane in that mix too, which is effectively, if carbon captured at the point of manufacture, is negative CO2. But that's a separate presentation and story. Next slide, please. The path to net zero will have stages, and we have the options available for that whole journey, from minimal blends of less than 5%, when that increases up to 20 or 25%, and then up to full 100% hydrogen. So we have every stage covered with our current product range. Next slide, please. This shows where we are on the product range. Our progress to date shows that the Type 4 has been certified for 100% hydrogen for over 18 months now, and the rest of our range will be available on 100% hydrogen within the next 12 or 18 months. The Type 4 is probably the most prominent that we see within the fleet of the NHS for CHP use. Next slide, please, Clive. Again, some technical stuff. Due to the higher flame temperature of hydrogen, we do run the risk of engine stresses, commonly known as knocking, and also a raised NOx emissions if these aren't checked. Next slide, please. But this is dealt with by monitoring the hydrogen content, so the control system can adjust both the NOx levels and reduce the peak pressures being the cause of the hydrogen stress. Next slide, please. Right, here we see the difference between a 20% blended hydrogen engine and a 100% blended hydrogen engine. Basically, it's how the gas is delivered to the cylinder. Less than 25% blend, air is mixed with the gas before the turbo, as it is with most products today. Whereas once we go over 25%, we're having to bring in the hydrogen at much higher pressures, and the air does not meet the gas until it reaches within the cylinder. But this technology we've been running on for 20 or 30 years, where we've been running on high pressure gas lines. Next slide, please. This is merely another visual representation of what I've just said. Existing products, sub 25% hydrogen, the gas and air meet before the piston, and on the right there, 100% hydrogen engine, where they meet inside the cylinder. Next slide, please. So today, running on 100% hydrogen, we are seeing around about a 30% reduction in electrical energy or output versus a current mains gas engine. But based on past and current evolution, our R&D departments are confident that as long as 100% hydrogen achieves widespread commercialization, that by 2025, we should be back to normal outputs, i.e. the same as what you would get out of current mains gas. So 100% hydrogen today is 1 megawatt, whereas on mains gas, it will be 1.5 megawatts. But we believe we'll be back up to 1.5 beyond 2025. And as we reach 2030, we believe we'll even advance beyond current mains gas outputs. Now, you'll be pleased to hear that your existing fleets can be modified to run on a mix and even 100% hydrogen, but cost and viability will depend on a case-by-case basis, basically where they are in their life cycle. Next slide, please. Now, our industry has a 20-year history of running on hydrogen mixes, as predominantly for takeoff gases, on flare gases, etc., of up to 60% mixes. But here's a suitable example, which is a current project that we're doing for a data center in the Netherlands that wants to be 100% green. These 6 1-megawatt engines will be running on 100% hydrogen. They will have 1 hour storage on site of green hydrogen. And in the unlikely event the grid failure is beyond 1 hour, they will automatically and seamlessly switch to the mains fed gas. So there's a project proving the concept that of all the previous slides. Next slide, please. Right, hydrogen is not the only game in town. We have other complementary technologies to reduce carbon. These include thermal and electrical stores that can reduce the engine running times. We have heat pumps running in conjunction with the CHP using previously lost heat that makes the CHP more efficient. And the electricity generated by a CHP on site can power all manner of other heat pumps and support the electrical charging infrastructure on site. Various carbon technologies used for today, so certain carbon capture technologies, some used today and some new, we look to put into commercial operation within this decade. You know, typical uses have been in the food and agricultural industries, but we have one in prototype at the moment with Severn Trent, which is actually producing precipitated calcium carbonate, which is used daily in production of paints, paper, and various other products. And then we also have smart energy grids, basically software which decides which energy source is best to use at any point in time using the site-based data and inputs from external providers, such as the energy costs and weather predictions to ensure that the lowest carbon footprint or the lowest energy cost, which are typically the same, is online and can even trade energy back to the network when incentivized to support the local grid network. So basically, there is no silver bullet. We use these to every technology we have, but when it's ready and not killing something today that has a clear benefit just because it might not look good. Now, quality CHP addresses all three aspects of the energy trilemma: sustainability, affordability, and reliability. It can also be used as your backup energy supply in the event of an electrical grid failure. I think that's it for me. Oh, sorry, one last comment if I can make. So yes, it may increase your scope 1 emission reporting, but the carbon offsetting described in the first slide can really reduce your carbon input today. As Chris Stark said of the Climate Change Committee this week, it's the cumulative effect of carbon that we're dealing with, not each individual site. So thank you very much. Using CHP is good for the environment. It alleviates the strained electrical system and also helps the public purse. Thank you very much.
Okay. I hope you're busy putting questions on the site. We've still got Sally with us. So if you just have any questions in, we'll put the answers to it. Now, looking at the NH Power, the collaboration, this is the collaboration of trusts and NHS England and the whole lot of us who are trying to help individual trusts get to net zero. We're just aware that between now and 2032, and the targets to get all the 209 biggest hospitals to net zero in terms of their gas, if we can, by then, it's 8 years, and it takes about 4 years to upgrade a site that needs serious work doing to it. The other thing is only hydrogen offers the retention of steam. All the other net zero routes need you to go low temperature. So if you can find a way, if you need steam or you need high temperature, hydrogen is possibly the best way available to you. Mains hydrogen is coming, and electrolysis, as you've just heard, is quicker. And if you attend our technology session next week, you'll find about another way of getting hydrogen quite quickly as well. Tankered hydrogen, I believe, is starting to be available, but it isn't actually here yet. So as part of the collaboration, we're trying to help you get your heat decarbonisation plans done because that's what needs to happen. The collaboration exists as a tool so we can all help each other and learn each lesson once and share it rather than each of us learning everything from the ground up. The intention is that you receive an invite to day 2 on the 11th to the Hydrogen Day, and hopefully you will leave that and any other workshop you choose to attend with an understanding of your route or routes to net zero, so you can make a decision as to which one's for you. And then we will offer support after that, which I'll come to in a second. So this is probably not the most up-to-date. I took this off the IHEM link a day or 2 ago. If you want to go to the workshops, please register. The link's in the invites you've had. On that, you will get the up-to-date list of speakers at the different sessions. So these are the 3 sessions on the 10th, which is not Hydrogen Day, and then the 11th is Hydrogen Day. So that's the main event and follows on from this event. And then we appreciate that whilst air source heat pumps are well understood in the NHS, they're not well understood at every trust. So we've added in an extra one on heat pumps and how you help trusts who've got heat pumps make the best of them. So there's an extra workshop on the end of it. So IHEM, if you can make it, is well worth attending, because you'll meet not only the speakers you've heard today and at any other talks you've met, is we've tried to widen it to other people. You've heard Sally today, but her colleague Martin, for instance, will be there on Hydrogen Day. We'll have other developers beyond Eric today, who's been present today, and we'll have other techniques of making hydrogen that we haven't discussed today available as well. So you'll rub shoulder to shoulder, be able to liaise with them directly and learn directly what they're up to and how they can help you get to net zero. So in addition, on the floor of the theatre, also in the free zone, we have the Energy Theatre, where we've got a number of talks, including a lot of the speakers that we've had on our workshops, who discussing individually and very close together. You can be really right next to each other and ask questions face to face and all the rest of it, and hear their stuff at the Energy Theatre talks, which are also free, and they complement the workshops. And we've tried to arrange times so that they don't clash with everything. So, starting on the 30th of November, we will start with the road shows. That's where we'll go firstly to the northwest, then the northeast, then the Midlands, southwest, and then the southeast. And we will understand or hope that you've been to as much of the preparatory stuff as possible. You've got an idea of which technology suits you, and we will make some tools available to you, and we will give you strategic outline case level costings for the cost and revenue implications of the work on your site, so that you can put that into your case and you know what you're talking about and roughly what it's going to be. Okay, the tool set under development for you is access to the map, because we've got you all mapped there with all your data and what's available to you and what's around you and the rest of it. At the moment, that's not in a suitable form for sharing widely, though we can do it on a visual basis. We'll make that so you can get hold of your site and see what it's about. And we'll have a project costing model for you, which you can put your site details into, and you'll get data from that. When you register for the workshops at IHEM, you will get a link to a very simple site, which you can fill in on your phone if you have to, answering some very basic questions that we need to supplement the data we already hold about your sites to allow us to arrive at the models and the best way forward for your site. So those are all underway as we are at the moment. Okay, as I've covered, they're the roadshow dates. They're currently on a Thursday. We're looking for venues at each of them. The Southwest have asked, could we change it to a different day? I'm not considering that, but I'm trying to stick to these days. The idea is we'll cover all the technologies in one session, probably starting 10-ish or so in the morning and going on till lunchtime. And the idea is you'll leave that having had a review of all of them and looked at the costing and what would be involved in your particular scheme. So you'll have the tools. So now we're on to the Q&A session. So we'll have an opportunity. We've still got a few minutes left where we'll first get Lorna to go up with any questions on the chat that be worth picking up more widely, Lorna, and then we actually have verbal questions if we've still got time left, if that's possible.
Yeah, well, we've got plenty of time there. There's no questions posted yet, so please, everyone, feel free.
Oh, excellent.
Go ahead.
Okay. Well, the one we often get is how everybody's heard a million colors. Have we still got Sally with us? Sally, everybody's heard a million colors of hydrogen smoke and mirrors and carbon captures bullshit and all that stuff. Can you just explain why it isn't?
Okay, so I've got a repeat from someone. So the government, sorry, I think someone needs to go on mute because I can't hear myself.
It might be you, Alan. Just check whether you're
It's
clean.
okay, no, I've muted them, so you can go.
Okay, so hydrogen production then, or hydrogen that goes into a new hydrogen pipeline network will all be compliant with the government's low carbon hydrogen standard. So that effectively sets very clear guidelines, or rules, I should say, on the carbon emissions that can be associated with the production of hydrogen. So if it's green hydrogen, the energy source is renewable energy. And if it's blue hydrogen, the hydrogen is made by splitting natural gas into CO2 and hydrogen. The CO2 is then sequestered off. But I suppose, as Clive has alluded to, any hydrogen that enters our new pipeline network will be compliant with the government's low carbon hydrogen standard. So any residual emissions associated with it will be within the tolerance that is allowed by government. So it'll be easy to calculate the carbon impact of the hydrogen, and it will be smaller than.
And it will improve over time without us having to do anything about it. So it's
yeah, that's the idea. So as time goes on, green hydrogen costs will come down and volumes of green hydrogen production will increase. And yeah, the availability of more and more renewable energy will allow more and more green hydrogen to be produced.
Brilliant. Okay. Have we got any more questions, Lorna?
No, Similar
Okay,
audience today.
Eric. Yes, Eric. Some trusts have got a plot of land either that they own that's not doing something, or that is near them. Can you just cover again? You half covered it. Could you cover again how that might be interesting to you and other developers as a route for producing hydrogen locally to the hospital?
Yeah, thanks, Clive. I mean, I think the kind of the three kind of basic kind of elements of what we need to kind of get hydrogen production there is, land that is relatively close to the off taker. So if we're within about 1 kilometre, that would be good, because then we can put a short pipeline in place. And then also, a kind of grid connection to feed the electricity into the electrolyzer. And just to kind of expand a little bit on Sally's point about renewable electricity. So we will only operate the electrolyzer when we can demonstrate that we've got renewable energy being generated from a specific asset on the system. So we can kind of confirm the greenness there. And then, yeah, so what we're looking at is, if you've got a demand of about 40 gigawatt hours per annum, that would be about 10 megawatts of electrolyzer capacity, which we'd need about an acre for. And we can basically site that electrolyzer in very close proximity to the to the off-taker, so to the hospital. So if you've got some spare land, we can look at how we can kind of site a facility on the site and then feed the green hydrogen in directly via a pipeline.
And how much capital cost must we give you to do that? And what are we going to pay for the hydrogen?
So, I mean, in terms of the capital cost, so as a developer, we meet all the capital costs for that. So we kind of completely pay for the construction of the electrolyzer facility, the construction of the pipeline, the construction of the electricity connection, planning, all the development work. So we basically do everything to bring the hydrogen to your boundary. So there's no capital investment required in terms of the electrolyzer itself. In terms of the price point, as Sally mentioned, there is a low carbon hydrogen standard, and if you produce hydrogen that complies with the low carbon hydrogen standard, you then can benefit from the hydrogen business model, which delivers hydrogen at cost parity with natural gas. In terms of kind of capex investment from the off-taker side, it depends really on exactly how you want to use hydrogen. So there may be some limited conversion work. So for example, if you've got some of the Clark Energy CHP plants and gas engines, there's a little bit of conversion work to enable the use of hydrogen. There may be a kind of more substantial investment if you want to, for example, switch boilers from 100% methane boilers to ones that can handle both dual fuel, both hydrogen and methane. And then obviously the way in which that's kind of, I guess, the view on how that's paid for is if you're in the ETS, so the emissions trading scheme, for every time you burn hydrogen instead of natural gas, you don't need to kind of acquire the CO2 credits. So the carbon savings or the avoided cost of the the UK ETS scheme is what pays for the capital associated with the installation of hydrogen ready plant within your site.
Okay, that's one of the things we're working on. So we're from the collaborations point of view, we're seeing it as in the fence and outside the fence. So your stuff's all outside the fence, and that involves no capital and no premium for hydrogen. Inside the fence, well, that's our job. We've got to get the hospital hydrogen ready to the extent that it needs to be, and that's what you covered.
Yeah, and just I mean, the other thing to kind of touch upon, which is quite important and quite challenging in terms of kind of doing it within the public sector. So we do have a couple of off-takers that we're working with right now who are in public sector. There's a challenge about how we go through the public procurement rules, because we'd be kind of bringing forward a project for a specific off-taker, and that kind of direct award is a challenge around public procurement. So that's kind of, I think, number one advisory to think about. And I think the second advisory is the low carbon hydrogen agreement is for a 15-year term. And that 15-year term is, a volume of hydrogen, and it basically provides the CFD mechanism to give the cost parity with natural gas. But again, we understand that that doesn't quite align with the kind of general public procurement. So there is a bit of kind of work that we need to do between the kind of hydrogen production industry with the kind of public sector and with government as well, to kind of give that easier commercial pathway through to the use of hydrogen in the longer term.
Okay, good points. Well, the 15 years we've cracked for the NHS, and the procurement, we've already done the first round of geothermal procurements, So the idea is that we'll put in place whatever procurements we need collaboratively, and then we can all share the benefits. So if 3 trusts want to go this route, or 5 or 10, we will look to group them together and do the procurements together. So there's only one set of cost and one set of admin and one set of procurement documentation to do. Okay, that's taken us to time. Lorna, unless there's something that's boiled up on talking, I'll say goodbye to everybody and thank them for coming. Was there anything come up?
No, nothing else has come up. I
Brilliant.
wasn't sure if in respect of the workshops at IHEAM, if you'd like the link to be shared for the questionnaire for trusts to fill in.
Well, it's on the invite, and so everybody, all the trusts who've been invited today and to the previous session and to the other technologies, all have invites for the session on the 11th, as they do to the other sessions. And on that are two links. One is for how you book the session on the IHEAM website, so IHEAM know you're coming and get you a badge or whatever it is they need to do. And then also is the simple questionnaire, which we'd like you to fill in before you come. It'll only take 5 minutes. It says, which trust are you? Who are you? And some very basic parameters about your site that we don't automatically know, so that we can actually put you in the right group and with the right other trusts in the collaboration discussions. Okay, on that basis, I'll thank everybody, thank our speakers, thank everybody for coming. I'll stop the recording in a second, and then it'll appear on the website fairly smartly for anybody who wasn't able to make the call who'd like to do this. Okay, thank you all very much.
Thank
And
you.
we'll see you,
Thanks,
on the 11th,
Thanks,
if
Lorna.
not sooner. Yeah.
Bye.
Bye.
Thank you. Bye.